Okay, good evening, Sir Ludi, and those who watch this video. This is my final exam project. My name is David Jozel K, 231412362. This is my project for SCADA Industrial Automation, and here is my background of my project. Wait a minute. Okay, so in this slide, we have background, context, and objectives. So first, for the project context, when we see a plantation of palm oil, coffee, and or tea, maybe a small scale plantation, they need irrigation system that is not traditional or not manually operated. So for the background, the operations are still manual and traditional due to traditional ways, it leads to over or underwatering or maybe under fertilization. So they need a system where it can be automated and controlled uh, via perhaps Telegram or maybe WhatsApp in order for it to be a lot more easier to control. So the objective is to develop an integrated SCADA system for real-time monitoring and control of irrigation, nutrient, bruising, and environmental parameters and improve water and fertilizer efficiency. So how we do it? We use the concept of SCADA, supervisory control and data acquisition. How? Well, we use the ESP8266 microcontroller board for us to communicate through the Wi-Fi chip in the board, for us to control it from far away and from much better and easier way than the traditional opening the valve or opening the irrigation system. So using this board, it makes us much more easier because from this board we can control it and connect it to a sensor. We have DHT and ultrasonic sensor. For DHT sensor, it reads the humidity and the degrees of the plantations. So when it's really coarse or maybe it's really wet, we can control it based on how do we actually want it to do. Maybe if it's really coarse, if it's really dry, we can uh, open the valve and open the irrigation system through the servo and opening the water for it goes to the plantation. Maybe when it's overwatering, we can control the servo to close the irrigation system and close the watering. And how we do it, we use it from the Telegram bot. So for the user guidance, number one is hardware and power up, connect the ESP board to sensors and actuators, set up the Wi-Fi connection, and for the Telegram bot setup, create the bot with botfather, node bot token, chat with bot, send any message, and retrieve the chat, and for the token, and flash ESP sketch in Arduino IDE in your laptop or computer, replace your Wi-Fi SSID or your Wi-Fi pass, paste bot token and chat ID, upload it to the board. So we could receive the data automatically for the temperature and humidity every 5 minutes. It's based on my code, but you can change it however you want, maybe every hour, every 2 hour, it's okay. And how to control the pump up or maybe just opening the fertilization or opening the irrigation system, just say open valve and the Telegram will receive it, or close valve, the Telegram will receive it and then send it to the ESP board, send it to the servo, and then open or close it. And troubleshooting tips: no data message, check Wi-Fi credentials and ESP online serial monitor, bot not replying, verify chat ID and bot token, servo not moving, confirm power, ground, and correct data pin. So check the code and check if it's connected in the right pin. Upload errors, select correct ESP8266 board in Arduino IDE and install board. And so for future development for large scale plantations, we migrate from ESP-based nodes to industrial PLC controllers because, let's be honest, for large scale plantations, an ESP port might not be up to the job. It might get overheated. So we need more and better at serial data monitor communications. So we use PLC controllers, integrate with SCADA software, ignition and wonderware maybe, or just human machine interface, which is a lot more better. Maybe use EcoStructure for the ladder diagram, centralized dashboards plus historical data logging, redundant network, Ethernet or Profinet for reliability. So just local area network, sensor fusion, PHD plus ultrasonic plus soil moisture plus pH probes for a lot more better data acquisition. Automated alarm notifications, maybe through SMS or email, remote parameter tuning, and risk management. So major differences between microcontroller is that it's a lot more deterministic input and output timing, high cycle rates, built-in safety diagnostics, and redundancy, scalable to thousands of input and output points. For the automation level and migration level, for the automation level, level number one is sensing and indication, local DHT and ultrasonic readings, LEDs only. So it only goes to the only goes to the maybe this one use Arduino, so just use it to pop up or just high and low. And basic control, ESP triggers pumps, servo, and thresholds, like my project. Proprietary control, PLC executes layer logics, guided monitors, optimization, closed loop feedback, data-driven schedules. So it's a lot more organized, smart industry 4.0, cloud analytics, predictive maintenance, and maybe using AI. So, and for the migration level, manual operation, hand water, visual checks, no logging, ESP-based prototype, DHT, ultrasonic servo, telegram alerts, just like mine, PLC pilot cell, local PLC controls, single zone, plus SCADA, human machine interface, and multi-zone PLC network, distributed input and output racks, centralized SCADA server. So there's a server that controls all the plantations, full smart plantation, MES or ERP, enterprise resource planning, integration, wireless sensor mesh, AI optimization. So with the help of AI, we can control this plantation in a better way. So the conclusion for my project is develop a cost-effective IoT prototype using ESP8266 DHT sensors, ultrasonic sensor, and servo valve, achieve real-time temperature, humidity, and water level monitoring via Telegram bot, enabled remote pump control with simple or open and closed commands, demonstrated clear benefits, reduce manual checks, faster response to environmental changes, data logging, and prototype scalable to industrial PLC plus SCADA for large plantations, offering higher reliability and centralized management. Migration path validated from manual ESP-based PLC pilot, full multi-zone SCADA system, lays foundation for future enhancements, sensor fusion, AI-driven irrigation schedules, and predictive maintenance. So there you go for my SCADA project. I hope this goes well, and I hope these are accepted very well for Saludi. Thank you so much for this one semester. And yeah, thank you. And if you have any questions, just maybe talk to me through Teams and I hope this final exam goes well for me. Thank you so much.